Hey everyone, in this video we're going to be looking at the big ideas for section 5.6. And the big ideas here, this is going to take just a little bit longer, but there's some important formulas that we want to look at. So let's start off with the multiplication rule. So our general multiplication rule says this, that the probability of A and B is equal to the probability of A times the probability of B given that A has occurred. Now, another notation that goes along with this is the probability of A, and then this symbol right here, which stands for intersect B. So be aware of that notation. So we've got and this notation for intersect, they mean the same thing. And this is equal to the probability of A times the probability of B given that A has occurred. Now there's some other things that go along with this, because this is the case no matter what. We've had similar formulas to this when we were looking at the addition rule. But if A and B are independent, if they are independent of each other, then the probability of A and B is just equal to the probability of A times the probability of B. And we know that this is true because if they are independent of each other, then knowing if one of the events has occurred does not change the probability of the other event. You know, if we think about our independence rule that we looked at in our previous lesson, you don't have to write this down, but I'm going to write it down to remind us. We know if A and B are independent, this is our independence rule, then the probability of A is equal to the probability of A given B. Let me write that another way. Okay, the probability of, so that it matches up with A and B are interchangeable. So let's write it like this. The probability of B is equal to the probability of B given A, which is also equal to the probability of B given the complement or not A. So if you really think about this, if A, well, let's start up here. The probability of A and B is equal to the probability of A times the probability of B given A. But if A and B are independent of each other, then this probability right here, the probability of B given A, is equal to the probability of just B. We said that down here in this independence rule that we learned in the previous lesson. So what I have underneath of the multiplication rule is true no matter what. Both of those are true. The probability of A and B is equal to the probability of A times the probability of B given A. And if we know that A and B are independent of each other, then the probability of A and B can just be the probability of A times the probability of B. All right, so let's move on to these at least one questions. So if you see a question that says at least one, what is the probability that there is at least one red marble or whatever it might be? What you need to remember is this. The probability of at least one is equal to 1 minus the probability of none. That's always going to be the case. So if I say, in a deck of cards that has 52 cards, I draw one card. What is the probability that at least, or what, I draw 17 cards. What is the probability that at least one of the 17 cards is a heart? That's probably not the best example because there's only, that definitely is not the best example, but that would be 1 minus the probability that none of them are hearts. And so it's the same no matter what. So the probability of at least one is equal to 1 minus the probability of none. I apologize for not coming up with a good example, but just know that this is the way you should approach these at least one questions. All right, let's talk a little bit about conditional probability. And this is an extension of the multiplication rule. But conditional probability looks like this. The probability of, the notation for it would be the probability of A given B. Well, that's equal to the probability of A and B divided by the probability of B. This conditional probability formula right here, or conditional probability rule, it works all of the time. And it is an extension of the multiplication rule. You know, this rule over here is just algebraic manipulation of this rule over here. If I were to take the multiplication rule right here and just algebraically manipulate things, then I would get this rule. Okay, so these two say the same thing. It just is saying it in a slightly different way. So these conditional probabilities, which remember are questions that are like given questions. It doesn't mean that every single given question or every single conditional probability question is going to say given, but when you do see given, you should be thinking conditional probability. All right, last big idea that we want to look at here are tree diagrams. So I'll box this off a little bit so that I can distinguish it. And I'm also going to bring this over here so I have a little bit more room. So a tree diagram looks like this. So let's say we have two events, A and B. So this one right here would be the probability of A, and this would be the probability of not A. And then let's say that this is, I have these other events that could occur. So this could even be A, or I'm sorry, not A. Let's call this event happening B, and this C, and this D. And then this right here is also B and C and D. Now, with a tree diagram, what we know is each one of these branches uses the multiplication rule to find a probability. So this first branch up here, the probability of A and B, so this right here would be the probability of A, and I'm going to use the intersection symbol, the probability of A and B. And it takes us back to this formula. This would be the probability of A intersect C, and so on and so forth. I'll do the one at the bottom just so you know. This would be the probability of not A intersect or and D. Okay. I'm going to add one more thing to this tree diagram so that you can see it. I'm going to do it in a different color. This branch right here would be the probability of A. This branch right here would be the probability of B given that A has occurred. Because this branch comes after the A branch. The B branch right here comes after the A branch. So this branch that I'm highlighting right here is the probability of B given A. That's why we can multiply those two branches together. Just to put this in here down at the bottom, this would be the probability of not A, and then the bottom branch would be the probability of D given that not A has occurred. Okay, whoops, get that out of the way. So again, it goes back to the multiplication rule. The probability of the complement of A and D is equal to the probability of the complement of A times the probability of D, given that the complement of A has occurred. So it all goes back to this multiplication rule right here. So those are the big ideas for this particular section. Hopefully this helps you. Hopefully you'll become more familiar and start using these formulas, and hopefully you have a great day.